Let's do problem 57 on page 69. Let's read the problem first. And here it is, right there. Let me zoom in a little bit. Shh. It says raindrops make an angle theta with the vertical when viewed through a moving train window. If the speed of the rain is v sub t, what is the speed of the raindrops in the reference frame of the Earth in which they are assumed to fall vertically? So the raindrops are actually falling vertically, but in this moving train it looks like they're moving at an angle like that. And what you want is an expression. You're not finding a number here. You're finding an expression. So in fact, so here's what's given. Okay, oh, thank you. So here's what's given. You got this window, and you're looking at this window, and the rain is falling like this, and it's making this angle theta. But we're not giving it a number, which is fine. And we want the velocity of the rain in terms of the velocity of the train and theta. So we want to find an expression for this in terms of this. And by the way, the higher up you go in physics, the more problems are like this. The higher you go in physics, the less you're going to use your calculator, and the more you're just going to derive expressions, which at first is kind of frustrating, but then you get used to it, and you actually prefer it, because then you don't have to bother to get your calculator out. So anyway, let's solve it. Now this is a relative velocity problem. And remember, with relative velocity, you can always write a vector equation that the velocity of the rain compared to the ground is equal to the velocity of the rain compared to the train plus the velocity of the train. Okay? You can always write it this way. The velocity of our thing in the moving reference frame plus the velocity of our moving reference frame will equal the velocity in our non-moving reference frame, the Earth. Okay? So, now happily, we can just construct it's going to make a nice right triangle for us. But here's what I'm going to do. Okay, let's start with this. Well, let's start with one of these two. What do we know? Well, we know the velocity of the train is horizontal. So I'm going to draw this. Here's the velocity of the train. Okay, it's horizontally moving that speed. Now, plus the velocity of the rain compared to the train. Okay, well, we know that that's at some angle from the vertical. So here's the vertical, and here's our angle theta. But I don't really know exactly how long to draw this. Here's theta right here. But I do know this, that it said the velocity of the rain compared to the ground is straight up and down. And so this vector is straight up and down. So I just kind of draw this plus this equals this. And notice that I'm drawing my arrows on my vectors. So the velocity of the train is equal to, the velocity of the rain is equal to this plus this. The velocity of the train plus the velocity of the rain compared to the train stays mainly in the plane. All right. Now, if this is theta over here, this is 90 minus theta, but this is also, so this has to be theta right here. And I want it in terms of the velocity of the train and theta. So, and I want this. So I don't really care about this hypotenuse, but I do want this. I want the tangent of theta is equal to the opposite over the hypotenuse. I mean the adjacent, thank you. So the velocity of the rain is going to be equal to the velocity of the train divided by the tangent of that angle that they gave you. And this is your answer. Now, in most problems that we solve in here, these would have been numbers, right? And you would be solving with, and then you would take this and plug numbers in to get an answer. So actually, this is shorter, because you do all the work and then you don't have to plug the numbers in. You just write it as an expression. Okay? And is that right?
Yeah.
That's the end. Okay. So the tricky thing, I think some of you drew like this. I saw the group one, they did this. They said, well, this is the velocity of the rain compared to the train, right? And then you said, well, that's going to be equal to plus velocity of the rain compared to the train plus the velocity of the train is going to be equal to the velocity of the rain. So this vector plus this vector equals this. That's actually a little bit easier than what I did. I just tried to stick with this. But remember, it doesn't matter. When you're adding vectors, it doesn't matter what order you add them. You can say, okay, well, the velocity of the rain compared to the train plus the velocity of the train is equal to the velocity of the rain. Actually, that's easier. Yeah, that's easier. The velocity of the rain compared to the train plus the velocity of the train is equal to the velocity of the rain. And then this angle, now theta, you don't have to do the alternate interior angles like I did. You can just, oh, there's theta, and that takes you right to that. Okay? This kind of a question makes a great multiple choice question, right? Because not a lot of long, drawn-out computation. If you can draw the picture, you can get to the answer fairly quickly. Any questions? Make sense? Excellent. That is all.